Okay, so we're going to look at a question all to do with the different types of energy transfer and the impact of that when it hits the surface. And the later part is what people tend to struggle with, but it makes sense to go through the question because all of it builds up towards the final part. So, first question asks you for the loss of potential energy as an object falls from 1.5 meters to the floor. So as soon as you see the words potential energy, what you should be thinking of is mgh. So we've got mgh. So obviously the mass times the gravitational acceleration times the height. And that will be the change in energy will be the mass, which isn't changing, g, times the change in the height, which is 5.8 times 10 to the minus 2 times 1.5 times 9.81, which equals 5%, will be 0.85 joules. Okay, so it asks you then for the kinetic energies for impact. So what must have happened is that gravitational potential energy has been transferred into kinetic energy. So the loss of potential energy must be equal to the gained kinetic energy. So again, that must equal 0.85 joules. Okay. So to go from kinetic energy to speed, so obviously kinetic energy half v squared. So that means that v equals 2 times the kinetic energy divided by mass, and then overall square rooted, and when you plug the numbers into that, you get 5.4 meters per second. Okay. So the next part of the question asks you to calculate the momentum, and momentum, which we always use the P for, is equal to the mass times the velocity, which is equal to 5.8 times 10 to minus 2 times by 5.4. When I'm actually calculating this, I will be using the unrounded version from the previous part, but just for the simplicity of answering this question, I'm going to write 5.4, and that should give you an answer of 5.8 times 5 0.31 Newton seconds. Okay, and some of you might not necessarily get the answer in Newton seconds, because 1 Newton equals the mass times acceleration, so kilogram yes, 2. So then Newton second is equal to kilogram meters second to the minus 1, which is so the two things are the same if you got the answer in kilogram meters per second. Okay, so the next question asks you to calculate what the average decelerating force is. So the first thing you think about is how do we go about calculating a force? So obviously we're going to use equation F equals ma. Okay, so we currently know what m is already, so what we need to do is calculate a. Obviously we know that a is equal to the change in velocity divided by the change in time. So we got the change in time in the question, so we know that part, and we know the change in velocity must be the velocity going in, so that was 5.4. It's 0.4, not minus 4. subtract 0 because that's the final speed because it says it's brought to rest, divided by the time, so 0.01, which is equal to, is that one. And then obviously to get the force, we take that acceleration we calculated and multiply by m, and when you plug all of the numbers into that, you should get, so that the acceleration is 540 meters per second minus 2, and then plugging that into the force equation, you should end up with 31 newtons. Okay, so the egg is now placed in a container that crumples on impact. Explain how that makes it much less likely for the egg to break. So there are key things you need to think about here. So if it's going to be less likely to break, that must mean that there's a lower force acting on. So you've got a lower force. So that'll be why it's much less likely to break. So why is it that we've got a lower force? Well, if we go back to the equation we're looking at, to calculate what the force is, we've got mass times acceleration. Now, if you're placing it in a container, that would actually, if we look at, slightly increase the mass. So you'd think, well, what? That would slightly increase the force. So it's obviously not that that's resulting in the lower force. So that must mean that the acceleration is much lower. Okay, so we need to consider our acceleration, which was dv by dt. Now, if you think about it, it's the same egg, it's going to be going at the same speed as the other one, so dv must be the same. So what's actually happening is that by placing a container around it which crumples on impact, you actually increase the time which the impact takes. So if you increase the time of the impact, you actually decrease the acceleration, and therefore you get a much lower force, which makes it much less likely that an egg will break. And the same principle is involved in having crumple zones in cars, for instance, because what happens there is that the impact takes longer, so you reduce the force, so you increase the likelihood of a driver not walking away without injuries, or lower the magnitude of the injuries they receive.